Hi, everyone. Welcome to Alexa X Systems, where we simplify DevOps concepts and help you to build modern infrastructure. So in today's video, I'll show you how to provision an Amazon EKS cluster using Terraform with S3 as the backend for state management. So I'll walk you through the entire process step by step so you can replicate it yourself and level up your DevOps game. Okay, so what are some of the prerequisites you need before starting? So you need an AWS account because we'll be provisioning the cluster in an AWS account. So this is what an AWS account looks like. You need an AWS account. Okay, once you have set up your AWS account, you need Terraform installed on your machine as well, okay? So you need to install Terraform on your machine, like on your VS Code. Make sure Terraform has been installed on your VS Code. Next, you need to make sure you have AWS CLI configured with access credential, okay? Like if I type AWS configure, you will notice that I already have an access key. I already have a secret access key. I have my default region configured, and I have my default output format configured already. Okay, so make sure you go to AWS. If I go to AWS now, when you go to AWS, you click on your profile, you click on security credential. So you need to create an access key. Okay, so go where it says access key, you click on create the access key, and make sure that you have configured your access key. Next, you can equally go to my videos on my YouTube channel. You're going to see a separate video on Terraform, how to configure Terraform, how to configure AWS CLI. I equally have a video on how to create an AWS account, okay? So the next is, make sure now that you provision an S3 bucket. So I'm going to provision an S3 bucket for you because it is part of this video. So this is creating a Terraform. This is creating an EKS cluster using Terraform with S3 as the backend for state management. We all know that when provisioning an EKS cluster, or when using our EKS cluster, we always have what we call the local backend. So the local backend is the backend that is always on our machine, right? That means we are storing all the information in our machine. But now we want to store all this information in an S3 bucket, okay? So this is what most companies will do. They will store the S3 bucket, the Terraform state file in an S3 bucket and secure it with the help of DynamoDB or a KMS key. So in this video, we're going to be using DynamoDB key. I'm going to show you that as well on AWS. I'm going to be showing you. So I'll first of all show you an EKS cluster. Type EKS. This is EKS Kubernetes Service. This is what we're provisioning. Cluster, as you can see, we have no cluster, and I will show you DynamoDB. This is what we're going to be using the Dynamo table for state locking to prevent conflict changes. Okay, and the next stuff will also be provisioning as an S3 bucket. S3 bucket. Perfect. So now that you now know everything that, like, you now know the prerequisites of this video, let's begin. So first, we'll provision our S3 buckets, okay? So I have provided a script for you so that this video won't be long, okay? So I've written the script for you, and I'm going to be explaining to you step by step how to edit the script, how I wrote the script, so you can change how, whatever way you want, okay? So you're going to see a script called EKS 2024. This script will be attached to this video, right? It's a GitHub link, okay? So you're going to navigate straight to the EKS 24. The EKS 24. Once you're there, you CD to where it says S3 bucket, okay? This is how to CD to the S3 bucket. So I wrote a Terraform script for S3 bucket. So this is it, S3 bucket. So you CD to S3, S3, ZB. Oh, sorry, you CD to S3, sorry, S3 dash bucket, S3 dash bucket, and ZB. Enter, enter, and next, you're going to do ls. You're going to do ls. Here now, you're going to see the script, this Terraform script, okay? So now you're going to see it says, this Terraform configuration creates an S3 bucket for storing Terraform state files. So I've specified everything you need to know, okay? So a Dynamo table for state locking. As I earlier told you, we'll be using a Dynamo table for state locking. So first, you need to put your Terraform provider, okay? You need to put your Terraform provider. How did I put this Terraform provider? You can delete it back. I will delete it. I'm going to delete it and put it back, okay? So I'm going to delete this Terraform provider. Delete, I'll type Terraform. I'm looking for provider. Terraform provider, okay? I'll just click enter. Now I have my Terraform provider. I like using the latest version. I'm going to choose version 5. Okay? So VS Code helps you to do autocomplete, okay? You just need to simply install a plugin called Copilot. Once you install the plugin called Copilot, Copilot is going to help you a lot. You see, when I want to write a script, Copilot does what we call auto-completion for me. You might not see this function on your VS Code. You will need to go to plugins. Plugin is always around here. You're going to see that. You search for Copilot and you install the plugin. Okay? Perfect. So once you've written your Terraform provider, the next thing is the provider. Which provider are you using? AWS. The next thing is your S3 bucket. So how did I get this S3 bucket for Terraform storage? And how did I get state locking or versioning and state locking? You go to the official Terraform documentation site. So some of these buckets has already been written by Terraform. So you see AWS S3 bucket with versioning. How do you search? You can just come and type AWS Terraform S3 bucket, S3 backend mode. It can still be backend, it can still be bucket, remote backend, it can still be bucket, it can still be bucket. And you go through this documentation, okay? You go through this documentation. So me, I was interested with the script that offers me version and the bucket. So this is it. This is without disabling versioning. This is enabling versioning. So most of these scripts, you just need to copy them and reference them back, okay? So now, as I earlier told you, Dynamo table state locking is for locking your backend so that we can avoid conflict, okay? So this was how I wrote this script and I referenced it. Very easy. And now, what do? You now start typing your Terraform commands as you know them. You now start typing your Terraform commands. I think I touched the version here. I touched the version. Okay, just I'm going to edit this. Modify. It's going to modify. Modify. Okay. Then I said, you might not see this, okay? So you see I corrected in 1 minute. It's because my system has an AI integrated, okay? So the mistake I made, it said corrected the AWS provider version. So I made a mistake and my keyboard touched something. So now I'm going to type Terraform init, Terraform init, wrong spelling, sorry. Terraform init, Terraform init. So once you have typed Terraform init, the next you'll be typing is Terraform validates to make sure your configuration is valid. Terraform validates to make sure your configuration is valid. Configuration valid. Next one is Terraform plan. Me, I've already created my S3 bucket, okay? So I created my S3 bucket when I was preparing for this video. So I'm not going to be creating any S3 bucket again because I already created this S3 bucket. So it says no changes. Your infrastructure matches the configuration. But for you, you're going to see the name of the bucket. So let me show you something. Before creating that, I forgot to show you something. You have to come down to S3 bucket for Terraform. Choose a unique bucket name, okay? Choose a unique bucket name. My name is Alexa H bucket. So choose a unique bucket name which you're going to use to provision. So scroll down the script, choose your bucket name, choose your environment, if it's prod, if it's dev, and that's it. So this script is helping you to do everything, okay? So you just need to change the bucket and maybe your environment, if it's UAT, if it's dev, if it's prod. Everything has been done for you, easy to use this script, okay? So once you have already created your S3 bucket, my S3 bucket was already created, okay? Let me show you the S3 bucket. Once you've created your S3 bucket, you can run this command. You can either go to AWS, let me clear my screen. You can go to AWS, you can do AWS S3 LS. You can run that command. Now it says there's a bucket called Alexa H bucket, you see? Alexa H bucket, okay? So if you go as well to, if you don't want to run that command, you go to S3, you click on S3, make sure it's in the region where you configured. Mine is in US East 1, okay? You're going to say Alexa H bucket. How did I configure my region? Let me show you. Here, you see the region, US East 1. Make sure you change your region. So that's why I equally put all of this so you don't get confused. Let me put this in front. Put this here. Perfect. Replace with your desired AWS region. Perfect. So now that we have created our S3 bucket, the next thing we're going to do now is we're going to provision our VPC. So now you have to cd here out, cd dot dot. You cd into the VPC. So I'm showing how to use my script, right? ls. So now I will come to the VPC. On the VPC, I'm going to show you how everything. So on the VPC, let me scroll down a bit. On the VPC first, since we are using an S3 backend, so first we have to pass that back end. So first, we are going to call this Terraform backend S3, the bucket. We want everything to be stored in our bucket, okay? So we don't want, if you watch my previous video on how to create an EKS cluster, you will notice that the EKS cluster we created, everything was stored locally, okay? Everything was stored locally in our environment. So now that we want to provision our S3 bucket, our EKS cluster, and store everything in our backend, so you have to pass now your backend while provisioning your VPC and your cluster. So here now, we have put the bucket name Alexa system. I suppose you already know the bucket. And the region, US is one. This is the region I'm using. So I put the correct region. So you can correct the region to your region. And now the key is very important. When we are going to provision this, you'll notice that when you click on S3 and go to your bucket, let's say Alexa H bucket, you're going to see the key, right? You're going to see the key. So this key is very, very important. So under your S3 bucket, Alexa H bucket, you're going to see VPC/terraform.tf state. This is where our state file for the VPC will be stored. Okay, so the state file for the VPC will be different from the state file of our EKS cluster. Our EKS cluster will depend on the state file of our VPC. You are going to see how we reference that, okay? So we now have the VPC, you now put your key VPC/terraform.state file. You can, of course, change this from VPC to what makes you remember easily, but I think VPC is the best. And now for state locking, as I told you, we're going to put them. So when we want to provision an EKS cluster, we'll just copy the same script and we'll also put at the beginning. Then now to create a VPC, you know how it is. Go to your browser, type AWS_VPC Terraform. It's going to take you to the Terraform registry, and you'll be able to see how I copied or I edited the resource AWS VPC, or if you've integrated Copilot or any AI tool in your VS Code. As you type resource_AWS VPC, it's going to show you everything to complete. So you're just going to change the name. So my own name was main. Of course, you can change it. And to create the internet gateway. So what are we creating? We're creating the VPC, internet gateway, Elastic IP, NAT gateway, private subnets for our cluster, public subnets, and private route tables, and public route tables as well. Okay? Public route and private route association, public association. So you're going to be seeing all of this. You're going to be seeing all of this. Nowadays, it's very easy to write script with the help of AI. You can just edit it. Or if you want to write from scratch, if you feel that you're so comfortable to write from scratch, you can go on. Okay? So now that we have the VPC, I wrote the variables here because here in the VPC, you notice that some of our script is going to be having var.private CIDR block, you can always pass all of those CIDR blocks directly, but it's always good to use variables, var.availability zone. You're going to see that now. I pass all of them here in the variable. Now you now see our public CIDR, that is it, public CIDR. You now see our availability zone, that is it, US is 1A, US is 1B. You now see our private CIDR, that is just what I pass. Doesn't mean that I cannot pass these CIDRs directly here. You can do it, okay? You could still come and pass your private CIDR here, those numbers, availability, pass them, all of them, but it is good to use variables. Now, provider is just my region. So the region is US is 1, then Terraform provider. This is even the easiest. Then output. Now we want an output, okay? So this output is going to help us. It's going to help our EKS cluster connect, because remember, our EKS cluster depends on the VPC. That is why we are creating the VPC first. And this output will help us to reference private, public, node, demo. It's going to help to reference everything for us. Now we have IAM rows. These are rows that will also be created, right? So we have EKS rows, we have node rows. If you have ever provisioned an EKS cluster before, or if you have ever heard about EKS cluster, we need permissions, okay? these permissions are found in AWS. Okay, so once you have created these permissions, it's going to give the possibility for your EKS cluster to be able to provision resources. So these are just all about permissions. If you want to know more about that, watch my previous video on how to create an EKS cluster. And now, roles and policies for node group. I set all of these roles and policies for node group as well. You can also set all of them. It all depends on you, okay? Roles and policies for EKS cluster. So make sure everything here is correct. EKS cluster demo, name, EKS node group. So roles and policies for node group, EKS node groups, node. Okay, and you have data.cf. Data.cf. So now let's position this VPC, okay? So what are the commands? You already know Terraform init, the first command. Terraform init. Now that we have a backend, it's going to be reading from our backend. It's going to be reading from our backend that is found where? In the AWS. Terraform plan. Terraform plan. You can run Terraform validate, okay? I'm running Terraform plan because I know my configuration is valid. So just to be sure your configuration is valid, run Terraform validate. So here you're going to see 24 resources to be created. 24 resources to be created. And the next thing I'm going to do now is Terraform apply -auto approve. Okay, Terraform apply -auto approve. Must you type -auto approve? No. Must you type that? No. Terraform apply you can also just type Terraform apply and it's going to prompt you to type yes to type yes. That's because I don't want to type yes. I want it to just provision without me typing yes. Okay. So once your VPC has been created, you're going to head straight to the cluster and we create our cluster. I'm trying to make this video very short so we can actually understand everything that is going on. Why our cluster is provisioning, let me drag this up a little bit. I am rows, permissions needed by our node. So this 4 is permission needed by our node. And this is permission needed by our EKS cluster, Amazon EKS cluster policy, Amazon EKS service policy. If you go and search your policy, you're going to see all of them, okay? Go to IAM. On IAM, you type policies and search all of these policies, you will see them, okay? Name EKS node group node. So this is just referencing. Our EKS cluster is currently provisioning. So our EKS cluster provisioning, take note, it will take some time. It will take some time. Make sure your output for your VPC was referenced correctly. Of course, you can change all the names from demo, node, or public or private. You can change. Make sure it was referenced correctly. So our VPC is being created. While our VPC is creating, let me go straight to our cluster. So I'll be explaining to you the cluster, why the VPC is provisioned. So here in cluster, I have a script for EKS. Now, I make sure that I wrote everything so you can read. It says this file is used to create an EKS cluster using Terraform. Next, it includes the necessary provider configurations. remote state data source, and the EKS cluster itself. So the cluster is created in a VPC defined in a separate Terraform configuration. The VPC is expected to be created in a separate model, and its state is stored in an S3 bucket. So congratulations, we have created our VPC. All the resources have been created. Let's head straight to our cluster, not to waste the time. Head straight to our cluster, CD cluster. Now, clear my screen. So now in cluster, as I earlier told you, we have our provider. You already know AWS is one. And now data. This is now where we are referencing the data that comes from the VPC. Because you'll be asking yourself that our EKS, our Terraform, our VPC is in another folder. Our cluster is another folder. So how will our cluster read the state file of our EKS? Because you'll be two different state files, okay? This is now where we put this data up here. Data means Terraform, remote state, network, backend S3. Now, Alexa H bucket, we are reading from VPC, okay? We are reading from the VPC/Terraform state file. Don't get confused. Now, come here, let me come back here. When we come on VPC, you notice that up here, where it was S3 backend, it was the key was VPC/Terraform state. Come back here to EKS. So we are telling EKS that you're going to be reading everything regarding the VPC from where? From this VPC/Terraform.state. So if you used a different name, make sure that you replace with the actual key of the network state. So this is the key, okay? And now we are now passing our own backend now for the EKS cluster. So you notice that on the key I changed to EKS/Terraform state. Don't confuse. Here was VPC/Terraform state. This is just data. This is implying that we are reading from that VPC. So this data imply that we are reading from that VPC. And now this is our backend for our EKS cluster. Its own key is EKS/Terraform, okay? And now it also has state lock and encryption on. And to create down the EKS cluster, you just need to choose a unique name. Make sure that you choose a good name, whatever name you want to choose. And now this is the VPC_complete, the subnet IDs, everything that was referenced correctly. If you want to know more, you can go to my previous video on how to create an EKS cluster. And now it says nodes. This is now for the node. Data block to read the local VPC Terraform state file. Make sure you can change the path to .tf state path. So now it says cluster name, AWS is EKS cluster.demo.name. It's going to read the name. Node group, private node. Private node. Subnet, you're going to see. Capacity here, we're just choosing T2 medium. How did I get this script? I got it from the Terraform registry. And that's it. Here, provider, we have just the regions, just the Terraform provider. You can as well add US is one, but I don't need this. So once you have your script already written, you have a good script provided by me, okay? So you can take this script and you can just add more resources, okay? Terraform plan. You can add more resources per your project. You can go on with this script. You can add more resources. So it says plan to be created. What will be created? Let's see what will be created. It says an AWS EKS node group will be created. An AWS EKS cluster will be created. Perfect. So let's create this cluster. Terraform applied as show to approve. So this is showing you how to create an EKS cluster. This is a video. Some people are going to actually show you how to do it in 3 hours, 2 hours, 30 minutes. But I'm doing this video for you in less than 40 minutes. You have a well-structured script provided for you. So this script is actually it includes a lot of things. So this script has version 1, 2, 3, 4, going to up to even 15. So this is just version 3 of the script, which is a little bit basic, which can create you a cluster. The other versions might have, you might see things like KMS, you might see things like adding users, adding admins. You might also see things like real-time projects, like a Netflix app, which we're working on. You might see a lot of other things in the upcoming videos to come, still in this very Terraform script, okay? Still in this very Terraform script. You might see Docker files, you might see a lot more different things, okay? So you can start with this script, and while you're working on your projects in your company, you can just be adding more projects and adding and adding and adding and adding. You have a well-structured script. You're just creating folders. So whenever you need to work on anything concerning EKS, it can help you. You just go to your EKS, and under EKS, you have folder for your VPC, for your nodes, folder to maybe add users, folder to provision your cluster, folder to maybe create namespace, folder to deploy your application, folder to expose your application, folder to maybe provision services like cluster IP, node port, Nginx, load balancer. You're going to be seeing all of that. So it's a script that has about 15 versions, as Ella said. So that is it. Our cluster is currently provisioning. Why is provisioning? Let's go to AWS. Now on AWS, search Amazon S3. You're going to see your bucket here. Click on your bucket. Click on your bucket. On your bucket now, you're going to see the keys, EKS and VPC. So this is where your VPC state file is stored. This is it. This is where your VPC state file is stored. This is where your VPC state file is stored. This is where your VPC state file is stored. If I click open, this is it. You can print. This is your VPC state file, okay? And when you come back to Alexa H, you're also going to see EKS. It has already created it. This is the state file. You click on it and you open. You can download it. So it's currently creating. Let me check. It's currently creating. Okay? It's currently creating. It's currently creating. So I'm going to pause this video and unpause it when it has finished creating, because it might take like 7 minutes, okay? So we can gain the 7 minutes. So now you can see we have successfully created our EKS cluster. We have created the worker node and we have created the cluster. So if you want to check and know how your cluster has been created, just run this command. Let me check. EKS, AWS EKS, describe dash cluster dash name, the name of your cluster. Okay, the name of your cluster and the region, and you click enter. It's going to appear. So this is my cluster name, Alexa H cluster, and everything. Now you can still go to AWS. You can still go to AWS. You can still go to your AWS and you search for clusters. And you see your cluster active, okay? You click on your cluster, health, perfect, everything is perfect. You scroll down to compute. You see your worker nodes, so the nodes are running, they are ready, everything is running, okay? Everything is working, resource, everything is running, okay? Perfect. So if you like this video, please give a thumbs up, share it to someone that is trying to provision an EKS cluster and having some issues. Share it to them, they're going to learn a lot. Of course, you can watch my first video on how to create an EKS cluster using a local backend. This was a video on how to create your EKS cluster using S3 buckets as your remote backend. So Very short video, very fast. See you in my next video. Bye-bye for now.